So hi, welcome to our first lecture. Today we're going to be covering the big theme of from molecules to organisms, and what that means is we're going to go from big things to little things, and little things to big things, and how that happens. So it's kind of interactions between stuff going on in your body. This centers around the idea of human physiology, meaning how your body works and how the pieces are connected. So for our first lecture, we're going to focus on something called homeostasis and negative feedback loops. So your big ideas for today, what you want to get away by the end of today, is how is your body organized? How is your body organized? We also want to look at the idea of what is homeostasis. And lastly, how is homeostasis maintained? So those are the three big ideas for today's lecture. While you're thinking about these, you also want to take some time to make sure that you think about the upcoming lab and maybe think of ways that you can disrupt homeostasis and maintain it. Alright, here we go. So first off, I wanted to talk a little bit about the theme of what molecules to organisms means. So our first theme on from what molecules to organisms means is again the idea that big things are made up of small things. So, for example, your body is one of those things. So there's a system of organization to get you. You were once one single unit. You were a single unit called a zygote. You were one cell, basically. You were sperm plus an egg. And now you're a whole big, gigantic, whole organism. So how is an organism organized? So the organization. So the smallest living unit in your body is a cell. A bunch of cells with a common function is something called a tissue. It's not Kleenex, but a tissue. There are four types of tissues in your body. These include things like nervous tissue, epithelial tissue, such as the stuff that's on the outside of your skin, loose connective tissue. So this would be stuff like fat that help make up your body. So you've got tissues, you've got organs. And what are some examples of organs? Things like your heart, your lungs are examples of organs. Together, a bunch of organs make something called an organ system. So typically, depending on your textbook and what professor you have, it'll be anywhere from 11 to 13 systems for your organ system. It's include stuff like your skin. So your skin is known as the integumentary system, which include things like your skin and your hair. One system that I'm going to touch on, because we're going to talk about it a lot, is the nervous system and the immune system. So what's the system that protects your body if you get sick? What protects you from bacteria and viruses? It's your immune system that's part of your organ system. And a bunch of organ systems make you. You're an individual known as an organism. So that's kind of our big idea and how we're organized. The key point is we're going to look in our book and we're going to try to find ideas for how an organism is built and what are some examples of organs and organ systems. Also in this lecture, I wanted to introduce homeostasis. This week we're going to develop a process for homeostasis, an inquiry project to how to counter your homeostasis. So to either counter, disrupt, or bring yourself into balance quicker. So first off, we want to talk about what is homeostasis. So your body is designed for this, homeostasis. Homeostasis was one of the vocabulary words from the characteristics of Life Lab. Homeostasis has to do with self-regulation and internal balance. And they can do this through a variety of methods. A lot of times it's a mechanism of cells and chemicals and hormones that makes you go through homeostasis. So big example, you go to PE, you run around, and you sweat. When you sweat, that helps cool you down. That's one example of homeostasis, and that's the one that we're going to be looking at in the lab. But how does your body maintain homeostasis? It does it through a mechanism called negative feedback. So a lot of people, when they hear the word negative, they think, oh, bad, negative. Negative feedback isn't that it's bad, it's that it's you're regulating. So there's kind of an endpoint. So when you think of this, you put it on an axis. On your x-axis, you have time, and we could look at something like blood sugar. So this one's really common, especially for individuals that have to deal with diabetes. If you're looking at your blood sugar, there's a endpoint and a low point. So you can think of it more like Goldilocks. It can fluctuate up and down, but once it goes out, it's got to come back. Goes too high, comes back in. We always want to be in that kind of Goldilocks zone. Not too high, not too low, just right. Goldilocks. You want to be just right. And that's what negative feedback is. So I'm going to show you a mechanism of how that works with blood sugar. So blood sugar is affected by what you eat and also your liver. So your liver is the main organ, so it's right around here in your diaphragm. It's a big chunk of your body, and it processes and it detoxifies. So it stores actually a lot of sugar, and it's tightly connected to the pancreas. If you ever look at a pancreas inside a rat, it looks like chewed up bubble gum. It's pink, and it's full of these little cells called alpha and beta cells that help release hormones, such as insulin and glucagon, that have to deal with how your body works. So kind of give you a little lie right there. It only releases one of those cells, insulin, which is why people who have insulin problems tend to get a transplant of the special types of cells in your pancreas. So to recap, your pancreas only emits one of those types of cells. So if we go back, we want to look at how sugar is affected. So we'll start with blood sugar. If blood sugar raises, it gets too high, your body has to store that. You don't want to have a lot of blood sugar floating around. So how does it counter that? Blood sugar is too high. So if blood sugar is too high, it'll release something called insulin. And what insulin does is it increases storage or uptake of sugar. So increase sugar uptake, and that in turn will decrease your blood sugar. Alright, so high blood sugar, insulin, we decrease that, we increase sugar uptake, so that means it's going into your liver, you're storing more storage. So the problem in diabetes is when this is cut out. In diabetes, you don't have insulin. For some reason, a virus may have infected you, you don't have insulin. So what happens? Instead of your body increasing insulin, your blood sugar stays high. So that was one of the big tests for diabetes. And back in the day, they didn't know better. They didn't know how to test for blood sugar. So they just noticed that people were urinating. They were voiding their bladder in areas, and were noticing that ants were crawling on people's urine. And they didn't know why, so they would sample urine, and they actually found, oh man, this guy's urine is sweet. So diabetes mellitus actually means like sweet urine. Copious amounts, meaning a lot of urine. So if you're urinating a lot, you're drinking a lot of water, and you still, a lot of thirst could be a symptom of diabetes. Getting more and more common nowadays because of people's diets and what they're eating. So that's a disease directly related to homeostasis. What else can happen if your blood sugar gets too low? So you don't eat for a while, you're just going to class, you're so busy doing all your work, going to practice, you're going to extracurricular activities, you're working at your job, you forget to eat. What happens? You don't just die and pass out, your body actually has a mechanism to protect you against that. So what does it do? Low blood sugar, it wants to increase it, so it releases a hormone called glucagon. And the way I remember what glucagon does is glucagon only shows up when glucose is gone. So glucagon shows up when glucose is gone. This in turn raises blood sugar, and that allows you to keep functioning during the day. So these are the two ways we keep negative feedback for blood sugar, using two hormones, insulin and glucagon, to take care of your body. Hey, so it's been fun chatting with you, and hopefully you learned some things about homeostasis. Again, if you have any questions, feel free to shoot me a message on School Loop. I'm here to help you, but remember, you got to put in the work and communicate with me with what you need help on. I look forward to seeing you soon, and take care. I'll see you later.